Okay, so I'm going to go over the queen problem. The queen problem is basically to write, given a chessboard, which is 8 by 8, we want to be able to place 8 queens on this chessboard so that none of them can fight each other. So basically, as you know, a queen can go this way, diagonally, right? So we have to be able to place queens such that no queen is in the path of any other queen. And here's the solution, by the way. So we can see on this 8 by 8, there's a queen here. This diagonal is empty. This diagonal is empty. This diagonal is empty. They're all out of each other's way, right? So how do you do that? And by the way, these would be the coordinates. So this would be your answer, right? So how do you solve this? Well, let's take a look. Basically, you start off by iterating through the columns. And then for each column, try to place the queen on each row. So going down the rows, place it in the first available place. So in keeping with that, we would place the first queen in the first row. Then we look in the next row. Well, we can't put it here. We can't put it here. Next queen can go here. Then the next row, queen can't go here. It can't go here because it's diagonal. Can't go here. Can't go here. Here's the next queen placement. Next queen placement in the next row is no. Yes, I believe that's where it would go. Yep. Next queen can't go here, can't go here, can't go here. We can go here, right? Next queen can't go here, 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 here. Can't go here. Can't go here because of this guy. So we can go in the 7th place. And then now, when we try to place this queen, we can't put him here because of the horizontals, right? We can't put it here because of the diagonal here. We can't put it here because of that diagonal and this diagonal. So there's no place to put the queen. So somehow we have to deal with this. Well, the solution is we need to go back one and try to replace this queen in a different position. So the way we do that is we're going to maintain a row. Each time we place a queen, we're going to maintain a collection of queens. So this is our queen, 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 right? And this is just going to have the x, y coordinates. So as we place queens on the board, we push them onto the array. When we get into this situation, we need to look at the column before, and we need to reposition that queen. So the column before, so let's say I'm trying to place this queen in my array, right? And I can't do it because I've reached the 7th one, and I can't place them on the 7th one. So I need to pop this queen off of the previous queen. That would be this guy, right? Pop this queen off of the array, and then starting with the next cell down, try to place the queen in a different place. Well, and the other rule is if the queen is already at the bottom, then I can't move it down anymore. I need to go back to one more and keep going until this works. So basically then, in this case, I would have to pop this queen. So essentially this queen is now off the board. And now for this queen, we remember the y, so this is where it was before. We're taking him off the board, and now we're going to start trying to evaluate this row. So can I put him in this row? Well, he's in the diagonal. Can I put him in this row? Well, he's in the diagonal. Can I put him in this row? He's in the diagonal, so I can put him here, right? Then once this one is placed, I would put it back on the array. So put it back, this time updating the coordinates. Now let's try to place this queen. And it looks like this queen can go here. No. I guess I should have done this up front. Okay, can't go here. Can't go here, can't go here, and can't go here. So we're stuck again. So now we need to go back. This guy's already at the bottom. So remove him from there. Go back one more. And each time we pop off the collection that we've done, and we reposition them all. So you see, that's the basic algorithm, and eventually you'll get to a point where you see how this queen started at this position, and now by backtracking, I've moved it all the way down to here, and then the other ones just fall into place. Who knows? You might have to go back and forth a few more times, but that's the basic algorithm. So let's see how this might work. Here's some sample code. One thing we have to keep in mind is each time I try to place a queen, so first of all, I'll have a queen array. So list, let's say, of points, queens. And then this is the list to which we're going to push and pop off of. Then the other thing is I need a method called check queen attack. And what that means is before I place a queen on the board, I want to see if it's going to intersect with any other queens. So basically I need to iterate through the list, and then I need to evaluate whether or not the queen will conflict with another queen. Well, to do this, first thing to check is that the not the same x coordinate, not the same y, because remember, up and down and across they work. But then to see if it's in a diagonal, we evaluate the formula x1 minus x2, absolute value, shouldn't equal y1 minus y2. That's how we know if it's on a diagonal. So this is my function to check queen attack. So now that you know the basic algorithm, here's how it works. I have this arrange queens. It has just the column counter and the row counter. And remember, I'm going to increment the columns. As I try to place queens, I increment the columns, and then I increment the rows to see where the queen can go. Once the queen is placed, I go to the next column. So these counters are passed in, and this is going to be called recursively. So the base case is, once I've taken care of all the queens, so max queens is going to equal 8, then I'm done, and that's it. And this array then contains the points. Another thing I've done is I've created a point class that just keeps x and y, right? So that's easy. So now in the body here, we just check to see if the point that you're evaluating, which is based on what's passed into this method, doesn't conflict with any other queens in the array according to these formulas, then I can just add it to the list, and then I increment to the column counter, because again, I do column by column. As soon as I place a queen somewhere, I increment the column. Let's try the next column. So I'll call arrange queens, incrementing the column, and we'll start at row 0, because we always have to start from the beginning, right? If the queens do, if I can place that queen there, then this will return true, means queen attack. So now we look in here. So now here's what we do. We're going to want to go back to the previous one, and then we want to see if the row is already at the bottom. If the row is at the bottom, then I need to start going backwards, actually. So I take that back. If I try to place a queen here and I see that it's equal to the x-axis, right, then I can't place them here, so I just increment and I try it here until I get to the last one. After I go to the last one, I can't go anymore, so that's when I need to start rearranging stuff. So I need to go backwards, backtracking. So the backtracking happens here. Basically, the previous index is the queen size, because I've only pushed this many queens. Now I go to the previous one. The previous y I'll set later, and then the column counter means which column I'm at. And then, so here I have a do while loop, and I'm going to say while, until I find a queen that's not at the bottom, I'm going to keep going back. So that's what this do while is. And for each one, so I get the previous y, and then I remove it from the list. Remember I said I removed from the list. And then once I've reached the point where I'm at a queen that's not at the bottom of the column, then I can call arrange queens again, passing in the column that's after the queen that's on, right? So let's say, so one more time. I went back to this column, and let's say the queen was here. Well, I don't want to try this element again, because I know this part already doesn't work. I need to rearrange it. So I want to start with this one. So this is the one that I'm going to pass in, and that's what's being passed into here, arrange queens, redo column. So it's the one, it's the previous y plus 1. Previous y plus 1, and then arrange columns. Otherwise, as I said, as I'm trying to place them, if I'm not at the bottom, I just increase the row, and I check to see if that one's good, check that one, and so on. So that's the queen problem.